In this video, we're going to talk about the two different forms of combustion, which are complete and incomplete. First, let's talk about complete combustion. Now, complete combustion is the reaction we talked about in the last video. We talked about types of reactions. We have some kind of hydrocarbon, like this methane gas here, being combined with oxygen gas, being burned to produce carbon dioxide gas and water vapor. So in complete combustion, our products are always carbon dioxide and water. This is because in complete combustion, the hydrocarbon fuel source is burned with enough oxygen to create these products. So the key for complete combustion is that it's done with sufficient or enough oxygen. So here we have our reactants. And what's going to happen is we're going to break these bonds and rearrange the atoms into the products for a complete combustion. So with any combustion reaction, we're going to form water first. So I'm going to take my two hydrogens and one oxygen for my first water molecule. I'm going to take another two hydrogens and an oxygen for my second water molecule. And you should see that I have one carbon, two oxygens left to form my one carbon dioxide molecule. So with complete combustion, there's enough oxygen to form water and carbon dioxide. But what about incomplete combustion? When we're talking about incomplete combustion, we're talking about a combustion reaction without enough oxygen to create that carbon dioxide. Let's look at this reaction. We have two molecules of methane reacting with three molecules of oxygen. What will the products be? So let's see, let's rearrange these atoms into their products. So first we're going to make some water molecules. I'm going to take one oxygen and two hydrogens and create my first water. And my second water. There's enough for another water. Remember, all the hydrogens get put into water molecules. Now I have two carbons and two oxygens left. I don't have enough oxygens to create two carbon dioxide molecules, so instead I'm going to create two carbon monoxide molecules. Now carbon monoxide is a toxic gas. We really don't want to be producing a lot of this where we can breathe it in. So with the heating systems in your home, if you have natural gas, it's always complete combustion, not incomplete combustion. And this is also why you'll see, along with fire or smoke detectors, there's carbon monoxide detectors in every home and building as well. So that's one option with incomplete combustion. You don't have enough oxygen to create carbon dioxide, you get carbon monoxide instead. There's another way we can have incomplete combustion. Let's look at that. So let's look at this reaction. We have one molecule of methane for every one molecule of oxygen. What do you think the products are going to be? Okay, so as with any combustion reaction, we want to make water first. So I make my first water. And I still have one more oxygen. 2 hydrogens. I can make another water. But now all I have left is this carbon atom. So when there's even less oxygen than when we form carbon monoxide, we just form solid carbon. If you've ever burned anything, you've probably seen this. It's known as soot. It's this black powdery stuff we get on the wood or whatever we're burning. This is solid carbon. So what you have to remember with incomplete combustion is that insufficient oxygen is available. So there's not enough oxygen to produce that carbon dioxide. And there's 2 different ways we can have incomplete combustion. The first option is when carbon monoxide is formed. So an example of this would be when 2 methane molecules are burned with 3 oxygen molecules. It creates 2 carbon monoxide molecules and 4 water molecules. The other option is when solid carbon is formed. An example of this can be seen when we burn 1 molecule of methane for every 1 molecule of oxygen gas. We get 2 water molecules and solid carbon as the products. Now, outside of laboratory conditions or really well-made machines like our heating systems, this type of combustion can be kind of mixed up. We might get some carbon monoxide, some solid carbon, some carbon dioxide molecules, depending on the level of oxygen at any given moment. But for the purpose of your chemistry class, these are the kinds of questions I'm going to ask you. What is the equation for the complete combustion of ethane, or C2H6? So I know what my reactants are. I've got ethane and oxygen, and then I need to figure out what the products would be. And I know that it's complete combustion, so I know that I'm going to have carbon dioxide gas, and of course water vapor, or gaseous water. And then I just need to balance my equation. So the easiest place to start with these is the water, because all of the hydrogen go from the hydrocarbon to the water. So I'm going to make those even. I see I have 6, so I need a 3 here. Now that I have 3 oxygen, I have 5 total. But this is going to have to be an even number. I also know that I'm going to have at least 2 carbon dioxides, because there's 2 carbons here. That brings me to 7 oxygens in total. But I know this is going to have to be an even number. So let's try this again. I need to make sure this is a multiple of 6, because there's always going to be at least 6 hydrogen. So instead of 3, I'll put a 6. Double that. That means I need to also change up this. Now I have 6, 12 hydrogen, 4 carbon, and in oxygen I have 8 plus 6 gives me 14, so if I put a 7 here, it should balance. Let's see, I've got 4 carbon, 12 hydrogen, 14 oxygen, 4 carbon, 12 hydrogen, and 6 plus 8 gives me 14 oxygens. Perfect. So this is the equation for the complete combustion of ethane. Let's try another one. Another type of question might be asking you for the equation for incomplete combustion. I will give you the hydrocarbon, and I will say what one of the products is. So if it's incomplete, it could either be carbon monoxide or solid carbon. In this case, it's solid carbon. So I know my reactants, and I also know my products, because I said it was solid carbon, and of course water as always. And then I just need to balance my equation. So I know there's only 1 carbon on each side, so that's fine. I need to double my hydrogen, which also doubles my oxygen. So that's all I need to do. Then I might ask you a question like this. How many oxygen molecules would need to be reacted with 1 methane molecule for complete combustion to happen? So it's complete combustion, so I know what my reactants and my products are. Now I just need to balance the equation to figure out how many oxygen molecules it would take to have this happen. So to balance it, I can see that I need to double my hydrogens. That means I have 4 oxygens, so I'll balance that out. So the answer is that I would need 2 molecules of oxygen for every 1 molecule of methane for complete combustion to happen. Now these type of question might involve you figuring out the equation for a certain type of incomplete combustion or complete combustion. And we'll be exploring the idea of combustion and the different types in class this week.